environment solving the classic info on any machine problem. So let's see what's role in modern software development for these containers. One of the pivotal roles containerization plays in modern software development is enabling a microservices architecture. In this architecture, applications are broken down into smaller modular services. Each of the services run in its container, which significantly simplifies the development, testing, and deployment processes. By isolating services in their own containers, developers can work on different parts like applications simultaneously without worrying about dependency conflicts. So this modularity enhances the flexibility and maintainability of an application, allowing teams to update or scale individual services independently. So which is a massive leap from the monolithic approach. And to scalability and critical containerization is its impact. Is it impact on scalability and the portability? Containers are like and startup quick, which makes deploying multiple instances of an application quickly, which makes it multi-instances as needed. This scalability is to deploy multiple instances of an application as needed. This scalability is crucial for handling varying loads and ensuring optimal performances. Additionally, the portability of containers is a game changer since containers encapsulate everything an application needs to run. They can easily move across different environments from a developer's laptop to a test environment and finally to production. So how integrate this with a containerized security with the DevOps? Containers also integrate seamlessly with DevOps practices, which is fundamental to maintaining continuous deployment and delivery, right? So in a DevOps setup, the goal is to automate the streamline the software development lifecycle and containers perfectly into this model, right? So they help maintain consistency across different environments, which is crucial for reliable and repeatable deployments. By using containers, you can ensure that their applications behave the same way in development, testing, and production environments, which significantly reduces the deployment errors. This consistency, coupled with the speed of reliability that containers offers, enables teams to deliver updates and new features rapidly without compromising any quality of stability. So let's identify the security challenges. So common security challenges in container security is like one of the most significant security challenges in containerized environments is vulnerabilities in a container images. Container images are essentially blueprints of creating containers, right? So if these images are not properly managed, they can harbor vulnerabilities. These vulnerabilities might have due to the outdated of software, misconfiguration of or malicious code embedded within the image. When exploited, these vulnerabilities can lead to severe security breaches, exposing sensitive data or compromising the entire application. It is crucial to use trusted base images and regularly update them to include the latest security patches. So insecure comment, the second point, the insecure configuration, which is like another common challenge. Improper configuration can inadvertently expose critical data and systems to potential attacks. For instance, containers might be run with excessive privileges or sensitive data might be stored in plain text within the container. So mitigate these risks, it is essential to follow best practices like setting appropriate permissions, using environment variables for sensitive data, and avoiding running containers as root unless absolutely necessary. Secure configuration acts as the first line of defense against many potential threats. So next point, runtime threats. Runtime threats is like such as a container escapes pose another previous risk. A container escapes occurs when a malicious actor messages to break out of the container and gain access to a host system. So this can lead to a full compromise of the host, affecting all other containers running on it, limiting container privileges, and applying strict security policies. Using tools like AppArmor or SELinux can help mitigate this runtime errors. Next one is network security. So network security finally issues arises due to improper segmentation and exposure. Containers of often communicate with each other and external systems over the network. If this communicate are not properly secured, it can lead to unauthorized access and data breaches. Implementing network segmentation using unauthorized access and data breaches. Implementing network segmentation and using the secure protocols such as SSL, TLS for data in transit, and crucial steps to protect the network infrastructure of containerized environments. So how this will impact the DevOps workflow, we'll see. So you know the DevOps workflow is mostly dependent on CI/CD pipelines. So let's examine how security challenges impact on DevOps workflows. Starting with the continuous integration, continuous deployment pipelines. CI/CD pipelines are the backbone of DevOps practices, enabling rapid and frequent updates to applications. However, these pipelines can also propagate vulnerabilities if each carefully managed. Each step in the pipeline, from code integration to deployment, presents an opportunity of vulnerabilities to introduced or missed. For instance, a vulnerable library includes in the build process can compromise the entire applications once deployed. To maintain a secure environment, it's crucial to integrate security measures within the CI/CD pipelines. This includes using automated security scanning tools to detect vulnerabilities in a code dependencies and container images before they are deployed. Additionally, implementing automated compliance checks and ensuring these security policies and enforced throughout the pipeline can help catch potential issues early. By embedding securities into every stage of the CI/CD process, we can significantly reduce the risk of vulnerabilities being propagated through development of cycles. Next is balancing speed and security. So balancing the speed of deployment with security is a constant challenge in DevOps workflows. The primary goal of DevOps is to accelerate the delivery of applications, features, and updates. However, the speed might not come at the expense of security. Rushing the deployment without doing security checks can lead to vulnerabilities being introduced into a production environment, potentially leading to significant breaches and operational issues. To achieve a balance, it's important to incorporate security practices that do not hinder the development phase. One approach is to adopt a shift-left strategy. When security is integrated early in the development process, by involving security teams and practices from the initial stages of development, potential automated security tools and practice such as continuous security monitoring and automated vulnerability scanning can help maintain high security standards without slowing down the deployment process. So that's all about identifying security challenges. Next. So let's see how we will secure the container images. So securing container images is a fundamental aspect of maintaining a robust containerized environment. Trusted base image let's see what's the trusted base image. First and foremost, always use trusted base images from reputable sources. Base images are the starting point of your container images, and using unverified sources can introduce significant risk. Reputable sources such as official repositories and well-maintained open source projects ensure that images are free from the vulnerabilities and malicious code. By choosing trusted base images, you can reduce the risk of introducing vulnerabilities into your containers from the outset. Additionally, many reputable sources provide digitally signed images, which offer an extra layer of assurance regarding this authenticity and integrity. Next, regular updates. But regularly updating container images is another critical practice. Software vulnerabilities are constantly being discovered, and keeping your images up to date with the latest security patches is essential for protecting against these threats. This means not only updating your application code, but also ensuring that all the dependencies and base images are current. Automated tools and scripts can help all dependencies and base images are current. Then streamlining this process by periodically checking for the updates and applying patches. Then by maintaining an up-to-date images repository, you can mitigate the risk of running containers with outdated and vulnerable software components. So let's see what is vulnerability scanning. Finally, performing regularly vulnerable scans on your container images is a critical for identifying and mitigating potential risk. Tools like Crayer and Trivey are specially designed for the purpose. These analyze your container images, identify known vulnerabilities, and provide detailed reports on security issues found. Integrating these scanning tools into your CI/CD pipeline ensure that every image is truly checked before deployment. This proactive approach allows you to address vulnerabilities early, preventing them from breaching protection and reduce the risk of exploitation. Next is enhancing runtime security. So once containers are up and running, ensure they operate securely and protected from this. That is essential, right? So let's see how this can implement in our production. The first strategy is limiting container privilege. So by limiting container privileges to minimize the impact of a compromised container. By default, containers often run with more privileges than necessary, which can pose significant security risk. If a container is compromised, running containers with the least privilege necessary reduces potential damage, and attacker with the least privileges necessary reduce the potential damage an attacker can cause. For example, avoid running containers as root whenever possible, and restrict access to only when files and resources that the container needs to function. By following the principle of least privilege, you can limit the attack surface and contain the impact of any security breaches. So let's see how security policies will become a strategy. Implementing security policies using tools like AppArmor or SC Linux is another vital practice. Sorry. These tools allow you to define and enforce security policies at the runtime level, providing an additional layer of protection for your containers. AppArmor, for instance, can restrict the capabilities of a container, such as which files it can read or write, and which network operators can perform. SE Linux offers more granular control over access permissions, allowing you to define complex security policies tailored to your application states. So by applying these security policies, you can enforce strict access controls and prevent unauthorized actions within your containers. Next is continuous monitoring. Continuous monitoring is crucial for detecting suspicious behavior and potential threats in real time. Monitoring tools can attack container activity, alerting you to any anomaly. So security incidents, for example, tools like Falco can monitor system calls made by containers and detect unusual behaviors, such as attempts to access restricted files or executed expected processes, etc. By continuously monitoring container activity, you can quickly identify and respond to security incidents, minimizing potential damage. This proactive approach allows you to maintain a high level of security and ensure that any threats are promptly addressed. So let's see how we can strengthen our network security. Strengthening network security is essential to protect your applications and data from potential breaches and unauthorized access. Let's explore three key strategies. First one is network segmentation, second one is secure protocols, and third one is the use of firewalls and access controls. So let's see what is network segmentation. The first strategy is involves isolating containers and services to limit the blast radius of the breach. By segregating your network, you can prevent a compromised container from affecting other parts of your system. This isolation is achieved by using network policies that control the communication between containers. For example, Kubernetes network policies can be employed to specify the containers are allowed to communicate with each other. So these policies act as a form of microsegmentation, ensuring that only unnecessary things can communicate are permitted. By limiting the integration between containers, you can reduce the risk of a single vulnerability leading to widespread damage. Additionally, isolating critical services within their own network segments can further enhance security, ensuring that sensitive components are protected from potential threats. Secure protocols. The second strategy is to use secure protocols to encrypt data in transit. Encrypting communication between containers and external services is crucial to protect against interception and unauthorized access. Secure protocols such as SSL, TLS provide robust encryption, ensuring that data remains confidential and tamper-proof during transmission. So implementing this SSL TLS requires configuring your services to support encrypted connections. This involves setting up certificates and ensuring that all endpoints can handle SSL TLS. Tools like Kubernetes ingress controllers can simplify this process by managing SSL TLS termination. By ensuring that all the data in transit is encrypted, you can safeguard your communications from potential eavesdropping and man-in-the-middle attacks. Next, let's see how the firewall and access controls defining the security network security. So the firewall and access controls using firewalls to control traffic flow and prevent unauthorized access. Firewalls act as a barrier between your network segments and external threats, allowing only authorized traffic to pass through. By implementing firewalls at various levels, such as the host, network, and application levels, you can create multiple layers of defense. Access controls are equally important in maintaining network security. These controls involve specifying who or what is allowed to access specific resources within your environment. Using role-based access control, ARPAC, and other access management tools, you can enforce strict access policies, ensuring that only authorized users and services can interact with the sensitive part of your application. For instance, you can define firewall rules that block all incoming traffic except for specific IP address or ports. This approach helps prevent unauthorized access and reduce the attack surface. By combining firewalls with well-defined access controls, they create a secure and manageable network environment. So, next one is configure containers securely. Let's see how we can configure our containers securely. So we can use three key practices: minimalist container images, implemented read-only file systems, and secure resource limits. So let's see our first key practice. Minimalist container images. So this is to reduce the attack surface. Like a minimalized container image contains only the necessary components required to run your application, minimalizing the number of potentially vulnerable packages and libraries. By stripping away unnecessary dependencies and tools, you reduce the avenues through which attackers can exploit your containers. So choosing minimalize as a practice, such as Alpine Linux, using Alpine Linux reduce the overall size of your containers and decrease the number of potential vulnerabilities. Smaller images and are easier to manage, to deploy, and less likely to contain secure vulnerabilities compared to the larger more complex images. Additionally, regularly updating these images ensure that you have the latest security patches, further enhancing the security posture of your containers. So next key practice is read-only file systems. So this is to implement read-only file systems within your containers. By default, containers often have read-write access to their file systems, which can be risky to security context. Implementing read-only file systems prevent unauthorized changes and tampering, protect your containers from malicious activities. This approach is particularly effective for production environment where containers should not modify their file systems after deployment. By restricting write access, you ensure that any attempts to alter containers file system are denied, reducing the risk of unauthorized changes and enhancing the overall security of the application. The next key practice is resource limits. So this is to set resource limit for your containers to mitigate the impact of denial of service DOS attacks. DOS attacks attempt to overwhelm our system with expressive requests of traffic, causing it to become unresponsive or crash. By limiting the amount of CPU memory and other resources that a container can use, you prevent a single container from monopolizing resources and affecting the performance of other containers on the same host. Setting resource limits ensures that each container has a fair share of resources and prevents one container from negatively impacting the availability and performance of the entire system. Kubernetes and Docker provide mechanisms to set containers is allowed to consume. By properly configuring these limits, you can protect your infrastructure from resource exhaustion attacks and ensure the stability of your containerized applications. Next, let's see the practical implementation. So, practical implementation is automating security in CI/CD. The first step is to integrate the security tools within your pipelines to ensure continuous protection. So CI/CD pipelines are integral to modern software development, enabling rapid and frequent updates to applications. However, these pipelines can also propagate vulnerabilities if not carefully managed. By integrating security tools such as vulnerability scanners, static code analysis, and dependency checkers into your CI/CD pipeline, you can automatically scan and check for security issues as part of your build process. So next one is regular audits and compliance check. The second tip it is saying that performing regular audits and ensure compliance with security standards and best practices. Securely audit and compliance check help identify potential vulnerabilities, ensure adhere to the security policies, and verify compliance with industry regulations and standards. So, maintaining this compliance with standards to CI's benchmarks, GDPR, HIPAA, or PCI DSS is crucial for protecting sensitive data and maintaining trust with the customers and stakeholders. By conducting regular audits and checks, demonstrate your commitment to security and reduce the risk of security breaches and compliance violations. So the continuous monitoring, the third step I would suggest for the continuous monitoring implement monitoring solutions to detect and respond to security incidents in real time. Continuous monitoring provides visibility into your containerized environment, allowing you to detect suspicious activities, unauthorized attempts, or anomalies that may indicate a security breach. Tools like Prometheus, Grafana, and Elasticsearch with Kibana can be used to monitor container metrics, logs, and events. Additionally, security-specific tools like Falco can monitor container behavior and detect abnormal activities that may indicate a security incident. By setting up alerts and notifications, you can respond promptly to security events and take appropriate action to mitigate the task. So, continuous monitoring not only help in detecting security incidents, but also aids in understanding your environment's normal behavior. So, enabling you to establish a baseline and identify deviations. Implementing robust monitoring solutions, you enhance your ability to protect your containerized application and respond swiftly to potential threats. So to summarize, container security is essential in modern DevOps environments, right? Throughout this session, we have covered various strategies and best practices to enhance the security and containerized applications. So, to summarize, the key takeaways for this complete session include the importance of securing container images, enhancing the runtime security of these container images, strengthening network security for the images, and implementing secure configurations while we are creating an image or configuring an image. So I encourage you to apply the discussed strategies to your containerized environments by adopting a proactive approach to container security. You can mitigate risk and protect your applications and data from the potential threats. Start by reviewing your current security measures and identifying areas for improvement. Integrate security into your CI/CD pipelines, perform regular audits, and implement this monitoring to ensure ongoing protection. Remember, container security is a shared responsibility and requires collaboration across development, operations, and security teams. Now, I would highly recommend to open this session for an interactive discussion. Please feel free to ask your questions or share your experience related to the container security session. And thank you for attending today. I look forward to our discussion and collaboration on this critical topic. Together, we can build more secure and resilient containerized application. Thank you. Hi Hardik, can I leave?